Hello everyone. First of all, I would like to welcome you all to this session on getting started with Azure by Azure Developer Community Pune and in collaboration with Reskill. Today's session will be beginner friendly and will help you get started with Microsoft Azure. The purpose of today's session would be to understand the fundamentals of Microsoft Azure. So the points that are going to be covered in today's session are to how to create Azure login or password and account, how to set up the subscription, benefits for students, how you can host an application and set up an virtual machine. So today, to guide us through all this process, we have with us expert speaker Dibya Som. So I would like to welcome Dibya Som and enlighten us on Microsoft Azure.
Thanks, Mrinag, for the introduction. Hello everyone, and I hope you all are as excited as I am, and we are going to learn about Microsoft Azure fundamentals, right? So let's start with the very basics. When and why do you need cloud computing, right? I hope my screen is visible to you. Um, so, okay. The Microsoft Azure homepage or the dashboard. So what is Microsoft Azure? We should know that before we dive deep into creating a virtual machine, getting the student benefits, creating a machine and deploying our projects. And obviously at the end we all will know how your future projects can leverage from Microsoft Azure uh, student packs, so that your future projects are scalable when deployed on Microsoft Azure. So to get started, what is cloud computing? So imagine that you have a program, you have a piece of code that works fine on your system, and now you want to make it public. You want to make your software available to the entire world, for the entire world to use. Now how do you do that? One single system inside your home which runs your program cannot do it, right? You do not, your system might go down, your network might not be that stable, uh, your system cannot handle that kind of load of millions of people using your program, right? Millions, imagine millions of instances of the program running on your system. It's just going to burn up the system. So how do we do that? That is where Microsoft Azure cloud native products come in, right? Microsoft Azure, Amazon's AWS, Amazon Web Services, then there is GCP by Google Cloud Platform. So all these products come in here. They provide you a bridge so that you don't have to worry about the infrastructure, right? There are three common terms that you might have heard about cloud, for about cloud products. The most basic one being IaaS, infrastructure as a service. Then there is platform as a service, and then there is application as a service. So there are lots of things, and what we are going to do today is going to be coming under IaaS, infrastructure as a service. We are going to use the infrastructure by Microsoft Azure and leverage it to host our product or our project online. So how will Microsoft Azure handle these problems which our local system could not? Now, when you talk about a cloud a cloud computing provider, for example, Microsoft Azure, you are virtually getting a limitless amount of computing power and storage. Now, how exactly limitless? Like you can write, for example, you can buy 1,000 terabytes of storage disk, and you can build a really expensive and powerful system with lots of gigs of RAM and all those things at your home, and maybe make your own server. But how expensive is that for you? And how do you upgrade your products? For example, your product is running on your local system, and due to some XYZ reason a bug comes up, or system crashes, and your maybe your electricity goes away and your system goes down. So how do you ensure that your product is always online even if the system goes down, right? These things which can happen inside a data farm, inside a server farm, or on, or more technically in terms of cloud, it's called on-premise systems. These problems happen in an on-premise system where you have to maintain and upgrade the system. Now, when you use a cloud native product, for example, Microsoft Azure, you don't have to worry about these things. You can focus on the business logic, you can focus on coding the application, on building the application, on scaling the application, and you can forget about these on-premise things like what happens if you are going to run out of storage, what happens if your computing power doesn't meet the standards. You don't need to worry about these things. Like what if your system goes down? Microsoft Azure is built in a way like if there is some database that you're using, this database, even if the actual physical database, the server farm in which your database is located, even if that data farm goes down, your data will not be lost because a replica of this data is present in distributed server farms. So you never lose the data, right? Even if anything goes down, there will be zero downtime because instantly a server from another data from or anywhere on Microsoft Azure servers will come up live, and your product is never going to go online. What if you're going to run out of storage? You can just pay for extra storage, you can subscribe for extra storage and get it started. Now you don't actually have to worry about upgrading the physical drives on your system to get storage. No, you don't need to do that. You just need to subscribe for more storage and you get more storage. So these are the flexibilities which Microsoft Azure or any cloud native product brings to you: virtually limitless amount of computing power and storage drive, right? So there are lots of things to explore on Microsoft Azure. Today we are going to learn specifically about virtual machines. So what is a virtual machine? A virtual machine is nothing different from your system. It's just that it's not right at your right on premise. It's in remote Microsoft Azure's server farm. It's operating from there. It's a virtualized system. There's a technicality in cloud native computing called virtualization. So through virtualization you can access this limitless amount of computing power and storage. So for example, this virtual machine, this you can configure your own virtual machine. You don't actually have to pay for buying these products. You actually have to pay for the amount of time your software is going to utilize these resources, right? And these billing cycles are very optimized. They calculate the exact amount of time for which your resources use the product. So for example, a virtual machine is actually a virtual CPU, a complete CPU. It has its RAM, it has its storage, SSDs, um, computing power. It has, you can configure every little thing it has. You can configure its network, and you can basically allocate a virtual system in a remote destination, and then you can access it from your computer. So that's what we are going to do today. So to get started, so that just so that we all are on the same page, I'm going to give you one of a dummy project that we can all get started with, and then we are going to host it on the virtual machine, right? So let me give you a quick overview of the project. You don't need do not worry about the code that is present on the system. It's not a part of today's lecture. All we care about is what this product does, right? Because for deploying a product to for example, to deploy a product to cloud, we don't need to learn about its inner functionalities, its algorithm. We need to know what are its um, runtime dependencies. What does it need to run? And that's all a cloud engineer needs to know to deploy a product. And yeah, apart from that, all the other cloud computing concepts that come in, right? Networking, scaling, and all those things, load balancing, etc. So there is a plethora of things. So to get started, this is a dummy project that I've built for today's session. And what it basically does is, first let me show you an example what it does, and then I'll show you that it runs on my local system. And as second step, by the end of today's session, we will have deployed this product on Microsoft Azure, and we are going to use it right from there. Okay, so that you can share your product this now. And the conclusion from today's session would be, this is how, for example, when you build your own future projects very soon, I hope you use Microsoft Azure to deploy them and make them live. Because you say somewhere that you have built a product, and then show the working product for someone to use and experience it itself, it speaks a different story, right? So that's the goal. How your future projects can leverage Microsoft Azure or any cloud computing tool for that matter. So to get started, this is a Node.js project. What this project does is it allows someone to provide an email ID and a photograph to create an account, and then store it in a MongoDB session. So I'll tell you how to set this project up on your system, and I'll share its GitHub repository right now. In the meantime, um, let me make sure that you all have access to this project. So I'm sharing the chat. I'm uh, I hope someone can share this link in the YouTube live session so everyone can access the project. You can fork it, start it if you want, and in the meantime, let's set it up on the system, right? So let's see how it works. So now there are some basic commands that you should know to set up a Node.js project. I have given the steps on in the README file. So if you open up the README file in the project, there is only two commands that you need to run on your terminal. If you are on Windows, then please go to Node.js website and just install Node.js. Like, even if that doesn't work, uh, not a problem, because we are all going to deploy this into cloud. So it's not a problem if it does not run on your system right now. Just clone the repository, right? Just fork and clone the repository, and we are going to use it, and we are going to use Microsoft Azure to deploy it. Do not worry if it does not run on your system. Just clone the repository. Now I hope everyone is aware how to clone a repository. Just write git clone and use the link that I just shared in YouTube live section, and that's it, right? Give me a second. Yeah. So that's all you need to write in order to in order to clone the repository on your system. Okay. So git clone and the name of the and the link that I just shared with all of you. So if you use this link, you would be able to get this a local this repository locally on your system. If someone is aware with Node.js syntaxes, you can start running it and testing it. Or I'm going to show you what it does, and then we are going to run it, deploy it together on Microsoft Azure. So let me quickly open up my terminal so that all the commands are clearly visible to you. I'll just go quickly to the repository, Azure workshop, right? Okay. Let me know if the text is visible to you or I need to make it larger. All right. So here we are in the repository. I'm in the project root folder right now, right? This is where I'm right now. Oh, here. So there are two basic commands that you should know to run a Node.js project. First, this is some initial setup to install Node.js if you do not have already. If you're not very well versed with Node.js, you can skip this step. I'm going to show you what the project does, right? So the first step in every Node.js project is you run npm CI, and some people prefer npm install. It's totally up to you. Well, I'm going to do npm CI. What it does is it will search for this package.json file here. This package.json file defines all the libraries that this project is using, right? Do not worry about what this libraries does. We here are supposing ourselves to be cloud engineers. We just need to know what packages are needed, we install them, we deploy it, right? That's how we roll, right? Okay. So I just ran npm CI, and it installed these 513 packages, some internal dependencies and stuff like that. 36 packages are looking for funding. I'm not going to do that. So once you run npm CI, then all you need to do is write npm start. This will start up the project and and it will spin up the server. Basically, this is the code for the server. What this server does is it allows you to give it an email ID and a photograph, and it stores it in MongoDB, and then you can go through the profiles, right? So once you get this message that server is listening on port 8080, it means the server is now live. Now just remember that this server is running on 127.0.0.1, which is your local IP. This IP never reflects a remote IP, okay? 127.0.0.1, as you might have already learned in your networking classes, academic classes in your college. 127.0.0.1 is a loopback address. It basically refers to your own system. So this is your system, and on your system on port 8080, port 8080 is like an address where the server is actually listening. And inside there, if you go to this particular URL register, you can use the project. You can actually visualize the project. So let's quickly see how it looks. If I go to 127.0.0.1 colon 8080, or a smarter way to do is just copy this link, right? So I just opened up the link, and here you can see that there are there is a field which takes two kinds of input. One, your email address. Let's go with optimus@prime.com, and I'm going to put my name, and I'm going to choose a file to upload, preferably your profile picture. Okay, there is a problem in my Google Chrome. It's not selecting any files. Give me a moment. There is something wrong with my Chrome. I need to reinstall it. In the meantime, I can show you from Safari. I don't know what's wrong. It's not receiving any kind of files. Okay. Um, there is some CSS issue. Do not worry. Let's use the front end. We are going to give email ID. Let's say divisum.azure@gmail.com, and we write our full name here, and then we choose a file. Let's say I choose my profile picture. I agree, and then I sign up. All right. Okay, cool. Safari is not working. What a nightmare. All right, I think Safari did upload the files. Yeah, Safari did upload the files, but it was not able to show the next page. So once basically you register, once you have registered, you will get your the name and the email ID that you used, and your profile picture is going to come up here. Right now, I'm not, for some reason my Google Chrome is not accepting file upload, so I'm not able to show what it actually looks like. We'll do that once we deploy it on Microsoft Azure. For now, you can see that it works on this particular port. It accepts a file, and once done, if you go to the explore URL, you can see with what email ID and what photograph people have submitted. Right now, the way this works, it's not important to us. What I'm going to do here is, okay, now we have seen how the project works. Now what we are going to do is we want this project to be running on Microsoft Azure and not just on our local system, because while this runs on my local system, you've already seen that it runs on localhost or 127.0.0.1, which is not accessible to the outer world, right? It only works on your system. So how do you make it accessible? Now that is when we go to Microsoft Azure. So let's see how Microsoft Azure can solve this problem. So first of all, I'm going to log out from my Microsoft Azure account and show you how to log in, get your credentials, and get your services running, right? Because that was the first goal of today's session. Okay. All right. So I have already created an account in Microsoft. I have already created a Microsoft account. So that's the first step you need to do. You should have a Microsoft account. Once that is done, log into your account, and preferably I use GitHub to sign in, because when you use GitHub, there is something called GitHub Student Developer Pack, through from where you can actually get free credits for your Microsoft Azure portal. So if you just quickly open up Microsoft Student Developer GitHub Student Developer Pack and go to Intro to Web Dev section, you can see that you actually get free $100 credits for Microsoft Azure. And how do you do that? You basically connect your GitHub account to your Microsoft Azure portal. So here I'm going to sign in through GitHub. I'll click next, and it will just connect to my GitHub session. Since I've already done that, I'm not getting the registration page. You will get a particular section wherein you have to just click on confirm on your GitHub profile, and that's it. Once you are in, you will have the free student subscription. Now we are going to use virtual machines to actually deploy our project. And meanwhile, let me check if I have any other browser installed so I can show you how it works. Okay, not a problem. I'll show you through Postman, right? I'll show you the project through Postman. Okay. All right. Cool. Oh, let me once quickly show you how the project works, and then we deploy it because Google Chrome was not working. I don't know what's wrong with my Google Chrome. Let me just quickly show you how it actually works. I need to go to form, and there are three in the code base. I can just show you quickly that there are three fields that it takes: an email, a text, and a file. So let's quickly do that, right? Let's quickly spin up the server, npm start, and then we go to my localhost 8080. Let's create a new postman collection. We go to localhost, and inside localhost at port 8080 our server is running, and inside there the register url. Now register url takes three things, right? It's going to be a post request, and it's going to take a form data. So the first thing that our server takes is an email. So now that the server is running, let's send a request to the server. So it will take an email, and that's going to be email id. I'm just using double V because intentionally, because uh, email repetition is not allowed, right? It will throw up another error for protection of obviously. Now the second thing that it takes is a name, and it's a text type. uh, so I'm going to say name, and I'm going to say so the postman part is not necessary. I'm just showing you, doing this to show you the working, because apparently my Google Chrome is not opening up file selector. And the third thing that it takes is a file, and the name is avatar, and it is a type file. So let's say the key is avatar, and all right, it's going to be a file, and here I'm going to say my profile picture, right? And I'm going to send a request. Okay, so now this is the response that we get from the server on a successful submission. Status 200. You can verify that here from the code. Um, Register and 200. Okay, res.status 200, and then it shows you this kind of page. Registration successful. Good job. Okay. With whatever name you register, this is what it will look like. User registration done. And now, if I actually go, once that you have created a request and you go to localhost 8080 explore, you're going to see the registration that we just did. So this is how the server works locally. We just verified that it's working locally. Now we are going to deploy it on Microsoft Azure so that anyone you share this link with can actually use this project. Because if you share this link, this is not going to work anywhere, right? Because this only works on my local system, and only my browser can access this link. So let's see how we deploy this into Microsoft Azure. So let's take a 2-minute break, and let's see if there is any question here on based on what we are doing right now. If there are any questions based on the project, please feel free to ask, or we can move with the next step of deploying this project onto Microsoft Azure virtual machine, right? So are there any questions? Hello, developer Preetham. Hello to yourself. Hello, you back. Welcome, folk. All right. So if there are any questions, please let me know, or let's move with the next step. In the meantime, please create a Microsoft account if you do not have already. Link it with your GitHub profile, and in the Microsoft Azure home screen, and start up your Microsoft Azure homepage. Okay, so this is what we all should be right now in this particular section. Okay, so I hope there are no questions right now. Let's proceed to deploy this application into Microsoft Azure. So I'm going to click on virtual machines, and I'm going to create a new virtual machine, right? On the left top here, you can see a create section. So it's a virtual machine, and right now I do not want to go with any advanced preset template. I'll just create a simple virtual machine, right? Now, to create a virtual machine, there are a few tabs that you can. There are these are the few things that you can control. The subscription is obviously Azure for students, right? This includes virtual machine, so don't need to worry if it's going to be an issue. Now, I've already created a resource group. This is nothing. This is basically a group to view all your associated projects in one place. It's like a project. I'm going to say Azure Workshop. Now let's give a name to our virtual machine. We can say Node.js Azure profile. And here we can select the region where our this region is actually the remote server farm where our virtual machine should be located. Now it's totally up to you. For now, you can choose any location. In production, we choose location wisely based on data policies, based on our client's location, so those kinds of things. Here, let's just go with the default settings. Image basically allows you to tell the Microsoft Azure virtual machine that what kind of operating system should be installed on your virtual machine that will be allocated to you. This default one works well for our project, Ubuntu Server 20.04 LTS, long term supported, right? So the Node.js works really well on this particular version of Ubuntu, or any version of Ubuntu for that matter. So let's go with the default setting. And give me a moment, guys. All right. And the next thing that we are going to do is size. Let's go with the basic settings. You can leave everything basic here, and take a note of this section: administrator account authentication type. Please make sure that you have kept it SSH public key. This is how we are going to access our virtual machine. The username can be Azure user or anything, up to you. It's totally up to you what you want to name. I'm going to keep it the Bisum. Now this is the default user that will be created within your Ubuntu system, right? So for example, this is what I mean when I say user. Oh, my server is still running. So right now, for example, when I type who on my terminal, I get the Bisum. So this is the basic default user on my system. So similarly, I'm again creating a user with the name the Bisum on the Microsoft virtual machine that will be allocated to us. This is important. Remember that the Node.js is your profile key. This is basically your name of the virtual machine underscore key. Only through this secret key you will be able to access your virtual machine. So take a note of this name, and please make sure that you have kept it generate new key pair, right? And make sure that all of these are open. HTTP, HTTPS, and SSH protocols are allowed on your system. Next, let's see the disks. So it's a premium SSD, and well, basically we are not using memory read write operation, so it really doesn't matter if you use premium or the standard hard disk. Not a problem here. Now the next thing that we're going to do is just review everything, right? The virtual network that it will be using is Azure Workshop Virtual Net. Keep all of these settings to the basic. Do not change anything. We are not going to um, we are not going to play with these settings right now. We'll do it later, to specifically with the networking security group. For now, just select all these things that are available, and skip load balancing. Right now we are deploying this for our personal projects and not a prod load, so we can skip load balancing for now. Um, we can basically skip this part. Advanced tags, you can get some tag, or you can add some tags to it. Azure, this is basically anything that will give you some kind of hint or some kind of labels to identify your project from a stack of 15, 20 projects, whatever is running on your system. So I'm going to say Azure Workshop Pune, this. Basically, when I look at my dashboard, I can see from the group of projects that, okay, we missed something. Okay, let's say this was Workshop Pune and review and create, right? So let's wait for a few minutes while our project is actually being created. In the meanwhile, it will ask you for a pop-up to download the uh, SSH keys that we selected. Remember, virtual machine underscore key, the file that will be downloaded to your system right now. Using that, we are going to SSH and set up the project within our virtual machine. So validations passed, create, download private key and create resource, right? Let's go for that. Okay, so here we have the Node.js azure.pem file. Now this file is very important for you because only through the secret key we can access our virtual machine, right? So let's go to virtual machines and let's refresh this section. Okay, it's deployment in progress. It's still not created. In the meanwhile, let's go to our local terminal and remember I just downloaded this file, so it's in the downloads folder and by the name node.js hyphen azure hyphen something dot pem. So I'm going to go into my downloads folder, cd downloads ls. I'm not going to it's a really huge list, so let's just do this. So if you go to the connect section, you can get the um, actual terminal command that you need to connect to the system. So if I go to connect and ssh, this is the command that you need to connect to the system, right? And you need to replace this private key path with the file that you just with the path to the file that you just downloaded. So let's paste this, and I'm going to instead of this private key path, I'm going to provide it the actual path of the file that we downloaded. So it goes by the name node.js hyphen azure, node.js hyphen azure profile key.pem. Now it will not work. I'll tell you that already. The reason that this will not work is because this is an unprotected private key file. Now, what is an unprotected private key file? We just downloaded it and we directly cannot use it because of some security reasons. So we need to make this file a read-only file. Now that's a security thing for some systems, and some systems do not ask for it. Mac asks for it, so I need to make it read only. Now the command to do that, and this command is basically same for all Linux, virtual, Windows, all kinds of system. You need to run chmod 600. 600 is a security number, is a numerical number that basically tells the chmod command to make the particular file that we are going to name right now read only mode. Now that secures the file. So it's going to be node.js azure pem. So now that we have run this command, it's a read only secured file. And now if we rerun the previous command, no ssh file location and your username followed by the ip address of your virtual machine. Now if I run this, I'm going to drop into the system, the remote system, I mean. Okay, so yeah, blah blah blah. We are inside the system, wsum at the date node.js azure profile. If I do ls here, there is nothing. I'm inside the virtual machine that has just freshly been created, right? So here we are going to set up our node.js project. Now how to set up the basic functionality, I have already given that to you here. Let's go to, well, I'm going to do something. I need to refresh one particular file which needs to be present. Yeah, I'm going to recreate this, restore, whatever. Doesn't matter. So if you go to the README file, I've written two steps. I've written two steps to install Node.js on your virtual machine. Cloud VM setup. You can see this in the README file of your GitHub link that I've shared. So copy the first command and just paste it here. What this will do is, hold on, this is 16. Okay. Just before installing it, just make sure that you make this 16, 15 instead of 16. Sorry, 16 instead of 15, because 15 is not widely supported. What this particular command does is it will go ahead and download the uh, required files for installing Node.js on the remote system, in our case the virtual machine. So that's done, and now just run the second command, install Node.js. That's all you need to do to install Node.js on the remote system. Right now, it has the Node.js runtime environment with it. Now we need to make our project source code available here to actually use it. So how do we do that? Obviously we'll use GitHub. So we are going to use the same link that I shared with all of you, https://github.com Vagar 1526 Azure workshops. So all I'm going to do here is again run the same command that you used some time ago to clone the repository on your system. Get clone here, but now we are cloning it on the remote Microsoft virtual machine. Now that the project is available, you can see that Azure Workshop folder is now here. Now we can go to Azure Workshop and we can open up the project, right? So all our files are now present here. Now, obviously, like any uh, Node.js project, we are going to install the dependencies that it requires. Like, let's just make sure that everything is available, right? Because we just installed Node, it is available. We install version 16, remember, we just changed it. And npm is also available. Npm stands for Node Package Manager, so it will install the packages that your project will require. Npm CI. This one command will basically read your package.json and install all the files that we have mentioned. Let it handle that part. Once all your files are installed, we're going to run the server. Okay, all right. Now, like the command goes, it's just npm start. All right, it cannot read Mongo. The reason being, due to, for example, the database that this current project uses is this. The database that it uses is basically my personal database on with my credentials. So if you have access to a MongoDB, if you have access to MongoDB Atlas, which is again free, do that, or you can run MongoDB on your virtual machine, Azure VM, and just give it a credential. There is a .env file in the project's root folder. This .env file stores the location for the credentials and location for your what do we say, remote database. Now the project requires a database to store the credentials. So feel free to create a database and get its MongoDB SRV link, right? So now I've not uploaded this particular .env file into the GitHub, obviously, because it has my MongoDB credentials. What I'm going to do is I'm going to create a .env file in the code here. I'm going to open that .env file with the nano command, and I'll just copy paste what I wrote here. Okay, so basically MongoDB connection string is an environment variable now that the Node.js project will look for, and it contains my user ID, password, and the remote location of my database. Once that is done, just press Ctrl plus O to save the file, and then Ctrl plus X. All right, so now if I read the file .env, it has all this data, right? Now the Node.js project will start up. I'll say npm start, but still it will throw some error. Let's see what's that. The code is running, right, but we cannot access it right now. Now the way we access it is we go to a Node.js our virtual machine. Let's go to home. From there, let's jump to virtual machines. This is the virtual machine that we just created. It's available. And then let's go to networking. So it has a public IP address. Let's copy this address. Copy. And I'm going to paste it here. This is a shareable public IP address and not 127.0.0.1 or localhost, which runs on your system. It's running on a cloud virtual machine and it's available publicly. Now, inside that, the Node.js project runs on port 8080 and the URL is register. You'll notice that this URL is not going to work. And that's weird because it was working on our system. Everything was working fine, but the moment we shifted it to Azure, it's not working. But the server is running here. So, what is the issue? Now, the reason is a networking subnet. You need to tell the virtual machine to expose port 8080 publicly. Obviously, in computing, as you know, if something is not necessary, it's not already there. So port 8080, the virtual machine doesn't know that the Node.js project needs to listen on port 8080 publicly, so it's not exposing that. You need to tell a virtual machine to expose port 8080 so that your Node.js can now get the requests. So let's stop the server here and let's go to Azure. And from here, let's go to virtual machine, not virtual machines. I'm going to go home. From here, you will see something called your resource group. The resource group is something that has all these projects inside it. So if you go to resource group, you can see that here we have everything that we built. This is the virtual machine that we created, Node.js Azure profile, and here you will see something called network security group. Node.js, it will have the same name as your Node.js project, Node.js Azure profile, and here it has Node.js Azure profile hyphen NSG, network security group. So open that up. Now here you will see why the project is not working. So you can see that these are the only inbound rules that are defined by default. Now, what are inbound? So let's understand it this way. Let's say that you have a virtual machine working remotely, and obviously when something works remotely, it needs to be secured because you don't want your best project to be hacked and generating revenue for someone else or leaking data and things like that. So everything is secured by default. So by default, it's a black box. It does not accept connections in anything that is not required, right? So here you can see that these are the only things that it has been set up for. These are the only ports on which it is listening and accepting connections. Sorry, these ports: 22, 443, 80, 3389. Now, this is what an inbound security rule is. And when an inbound security rule is given to a network security group or is attached to a network security group, these policies define how the virtual machine is going to expose or handle requests incoming. For example, if you look at here, you can get a description of all the rules and how it works. So on the left hand side, you see the priority. If the number is higher, that is the rule that, like, if two rules are in conflict, then the number with the higher priority will overrule it, right? So this is the rule. This is the type of protocol that particular rule accepts. Now this is the port on which this rule is applicable. um, then there is this TCP protocol, and any connection coming to port 22 must have a TCP protocol on it, else it's going to be denied. Source can be any, like, we are not blacklisting or whitelisting certain IPs, we are accepting everything. And the destination is obviously any here. If we can configure it. A destination is if any request comes to port 22, then where should it be engaged into. These are some basics about ports and security inbound rules, but now we need to modify it to listen to our port, and we know that our server runs on port 8080, and this is not accepting any inbound connections because it's not visible here, right? So it's not accepting any inbound connections. So we need to open that port, expose that port publicly so that our server can actually get the conditions. Now I hope all of you are on this, all of us are on the same page. What is the problem here and why is the server not accessible? Basically, the server is running inside the virtual machine, and on the inside of the server, port 8080 is being listened to. But the problem is on the exterior part, port 8080 is blocked. So from the outside it's not getting any request, and from the inside it is listening. Now that is the problem. We are not able to access it because although it is listening from the inside, but the request is not allowed to go in. So using the security inbound security rule, we can update that. So let's do that. On the left hand side, go to inbound security rules. So these are the rules that are currently running. So let's add a new rule here. The source, let's keep the source on any, and source port ranges keep it at default. Destination is going to be, yeah, keep the destination as any. And here, the service, keep it as custom, and the port number is going to be 8080 because that is where our Node.js server is listening. And you can keep all other things by default. That's going to work for us. And on port 8080, like this is the name of the port that we are going. So to make it just more meaningful, I'm going to say Node.js app because the Node.js app listens on port 8080. This is basically a variable name that you have to assign. Add it. So let's wait for the security rule to be created. All right. Let's refresh and see the new security policies. These are the new security inbound policies. So we have Node.js app. It listens to port 8080, and the protocol is any. So it accepts all incoming requests on port 8080. Right now, let's run the server again. All right. Now let's go to port 8080. All right, so we are on port 8080, right? So this is what it looks like right now. The CSS is not accessible. We'll fix that also later. And here we can now see this is the so basically the port where I am in right now. Uh, the public IP port 8080 register, and now this works, right? Because now we have allowed incoming requests here. So now this web page is accessible. Now this web page is now going to send requests to our server. So let's quickly test it from Postman if it works. Let's copy this address, the public IP. Instead of localhost, that is going to be the public IP, HTTP, public IP, port 8080, and register. So let's send a request. All right. It gave us an error. Interesting. A user is already registered, right? Because we already created an account with this name. So like any good developer, let's add one more fee to promote duplicacy, and let's send a new request. Great. So now, good job. User registration successful, and the page has been, and the user has been successfully registered. Now, if we here go back to the public IP address and say explore, here you can see basically all the people that have been registered on our application. Now the images are not visible because now that requires some extra configuration for our virtual machine to be done, which we can discuss later, because that includes another product of Microsoft. Because normally you do not render static files from your server. The static files need to go into a data store, and that is something you should learn about. It's not very tough. It's basically a remote, it's something like Google Drive, but a programmatic Google Drive, right? So it's a remote storage where you can keep all your static files and let the server handle all these dynamic things. So here we have all the people that we have registered, and here the triple V that we just created. So everything is working fine and available remotely, right? And if we go to the server, you can see that it's showing us all the server logs. User email failed because this was already created. Status, user registered. This was the user that we just created. And now you will see a problem. The moment I stop the server from here, it's going to fail because the server will run only up to the point that the npm start command is running. The moment I close this terminal, the server will also stop. So how do we make our node.js project running remotely live even if we close the terminal, so that we don't ever never have to keep this terminal open and the project is always running? So for that we have to use another npm um, a tool called pm2. So I'm going to use npm IG pm2. Now, -g, the G flag basically says a global install. I'm going to install this PM2 thing. All right, I need to do sudo npm I PM2. All right, so now PM2 is installed. So let's start our server now with PM2. All we have to do is PM2 server.js. All right. It needs to be a global install for PM2 to be globally accessible on the command line. So I'm just doing global install with sudo permissions. Now, if we use PM2 start server.js, right? So it gave some basic default settings. PM2, there you go, big and life. Server port is running. This is the PID of the program. The server is online. And now I'm going to close the terminal. Control D. I just exited the terminal, and now I'm back on my local system. Connection closed. Now let's verify if our application is still running. Let's go to the deployed URL. Command Y. Explore, right? It's running. Let's go to explore. It's running, right? We can use the system. So that was all about how you create a virtual machine, how you deploy it, and I hope it gave you some insight how to use Microsoft Azure cloud computing tools and all the other interesting products that come with Microsoft Azure. This was only one of it, which gives you all the flexibility of a remote system. Now there are lots and lots of services that you can use for your projects. There are serverless functions. There is Kubernetes. You can run container, your Docker containers. If you have your uh, if you have a microservice architecture, or if you have a DevOps, a CI/CD pipeline, you can use lots of different projects. And this was an quick introduction to virtual machine and how to run your local projects on Microsoft Azure, so that your projects can leverage the virtual, non unlimited computing power, global presence, and basically you can make your projects available online, right? So if there are any doubts, please let me know in the chat, or we are good to wrap up the session, right? So I hope there are no doubts, and I hope all of you could learn something new today, how to use Microsoft Azure to, and how all your future projects can use Microsoft Azure to, um, be globally available, make it publicly available for other people to use and experience your products first hand experience, and not just a remote video explanation and things like that. And okay, thanks, Sayam, and everyone who attended the session. Thank you for your time, and I hope I see your project soon on Microsoft Azure or any cloud native service provider for that matter.
Yeah, so thanks a lot, Divyasum. It was really an amazing session. Got to learn a lot of new things, and that too from basics, like how you can, like you told, how you can get the Microsoft Azure credits by availing the GitHub Student Developer Pack. So I think it was very insightful and very knowledgeable session for beginners who are just starting in cloud computing and getting started with Microsoft Azure. So it was really an amazing session. Thanks a lot for your time and great knowledge.
My pleasure. I hope the session was insightful.
Yeah, thanks.
Okay, thank you, everyone.